Let's practice solving some absolute value inequalities together. For this very first practice problem here, we have a pretty interesting scenario. So we have an absolute value on the left side, and we are told that it is less than -6. Now, keep in mind that absolute value must be equal to 0 or higher. It can't be a negative value, so we can't take the absolute value of this expression on the left and have it be less than -6. That's just not possible. So for number one right away, if you see that you have an absolute value expression isolated on one side, but then it is less than a negative number on the right side, we can go ahead and say that there's going to be no solution for this problem. All right, so just be on the lookout for those in the future. For number two, we have the absolute value of this 6 plus 3x, and that's greater than or equal to +12. Now, since this is greater than or equal to a positive number, this is definitely possible, so we can continue with solving this problem. Okay, let's go ahead and split this into two different inequalities. So first one is going to be 6 plus 3x, and it's going to be greater than or equal to 12. So that'll be one inequality we can solve to get solutions here. A second one is going to be 6 plus 3x. It's going to be less than or equal to -12. Okay, let's go ahead and solve each of these. The one on the left, let's start by subtracting 6 from both sides of the inequality. Subtracting 6 from 6, we're going to end up with 0, and then have 3x is greater than or equal to, and then 12 minus 6 is 6. And then we'll go ahead and divide both sides by 3. If we go ahead and do that, we're going to get x is greater than or equal to +2. And then for our inequality to the right, let's go ahead and subtract 6 from both sides as well. Taking away 6 from 6 on the left side, we're going to get 0. So we're going to be left with 3x is less than or equal to, and then -12 take away 6 here is -18. And then we can go ahead and divide both sides by 3. If we do that, we're going to have x is less than or equal to -6. So putting together our pieces here, we can say our solution here is x is less than or equal to -6, or x here can be greater than or equal to +2. This would be our solution. For number three, we have the absolute value of 5 minus x, and that's going to be less than or equal to 6. So that's possible, right? We're definitely going to have some positive numbers that are less than or equal to 6. That's possible. So let's go ahead and split this up right away. So we have 5 minus x, and that's going to be less than or equal to 6. And then our second scenario here is going to be 5 minus x is going to be greater than or equal to -6. Okay, let's go ahead and solve the one on the left here. We can go ahead and take away 5 from both sides. If we take away 5 minus 5 on the left side is going to be 0. So we'll have -x is less than or equal to +1. And to get rid of this -1 coefficient, let's go ahead and divide both sides by -1. Keep in mind that if we divide both sides by a negative, we have to flip the inequality symbol so that it becomes greater than or equal to. And then on the right side, 1 divided by -1 is -1. For the inequality to the right, let's go ahead and take away 5 from both sides as well. If we go ahead and do so, on the left side here, 5 minus 5 is 0. We're going to be left with -x is greater than or equal to, and a -6 take away 5 is -11. Then to get a +1 as a coefficient, let's go ahead and divide both sides by -1. If we do that, we're going to get x, and then we're going to flip this to be less than or equal to +11. All right, so putting these pieces together, we can say x is greater than or equal to -1, and here x is less than or equal to 11. That's one way we could write it, or we could also write it another way, and since this is an and one, we can say this is -1 is less than or equal to x, just kind of turning this around here, but that's going to be less than or equal to 11. Either of these would work. For number 4, we have the absolute value of this 1 plus x, and that's greater than or equal to +6. Sure, there are plenty of positive numbers that are greater than or equal to +6, so no issues for this one. Splitting these up, we can say 1 plus x is going to be greater than or equal to 6 for one of our inequalities, and then 1 plus x is going to be less than or equal to -6. All right, solving our inequality on the left, let's take away 1 from both sides. If we take away 1 from both sides here, 1 minus 1 is 0 on the left, so we have x is going to be greater than or equal to 5. And then for our inequality on the right, let's go ahead and take away 1 from both sides as well. If we do that, those 1s are also going to cancel out. We'll have x is less than or equal to -7. All right, so combining these two pieces together of our answers, we can say that x is going to be less than or equal to -7, or we can say x could be greater than or equal to +5. This would be our solution. Here's number 5. For number 5, we have the absolute value of this x minus 4, and that's less than +3. Sure, there are some positive values that are less than 3, so this is solvable. Let's go ahead and continue here. Let's split this up. So we have x minus 4, that's going to be less than 3. That's one scenario. The other one here is going to be x minus 4, that's going to be greater than -3. Okay, let's go ahead and solve this. On the left side, let's add 4 and add 4 to both sides. Adding 4 to both sides here, this -4 and +4 cancel out, so we're going to get x is less than +7. And then for the inequality to the right, let's add 4 as well, just like this. If we go ahead and do so, that -4 and +4 will cancel out. We're going to get here x is greater than +1. Combining these two pieces together, we can say x is greater than 1. This is going to be an AND inequality, and we can say that x is less than 7. This is one way to write it, or we can turn this into one whole piece and say that 1 is less than x, right? If x is greater than 1, then we can say that 1 is less than x, but this x is going to be less than 7. So it's sandwiched between 1 and 7 here. These would be two ways to write our solution. For number 6, we have the absolute value of 1/3 of x minus 2 is greater than 1. So just checking over here first, I'm sure there's tons of numbers that are greater than 1, so we can get started with splitting this up into two different inequalities. Okay, so no issues there. We have 1/3 x minus 2, that's going to be greater than 1, that's going to be one of ours. The other one is going to be 1/3 x minus 2, and that's going to be less than -1. So these are going to be our two split up inequalities to solve. On the left side, let's start by adding 2 and adding 2 on both sides. If we do that, we're going to have those 2's cancel out, and we'll have 1/3 x is greater than +3. And then on the left side and the right side, let's go ahead and multiply by 3 and multiply by 3. On the left side, the 3 times 1/3 will cancel out to become just 1x, or x. And on the right side, 3 times 3 is 9. So x is greater than 9 would be what we come up with there. And then on the right side, let's go ahead and add 2 and add 2 to both sides of the inequality. The -2 and +2 will cancel out. And we're going to get here 1/3 x is less than +1. And then we can multiply the left side by 3 and multiply the right side by 3. 3 times 1/3 x is just going to be 1x, or x. And then x is less than, and then 1 times 3 is going to be 3 on the right side. Putting these two pieces together, we could conclude that x would be less than 3 to make this inequality true, or we can say x would be greater than 9. So this would be our answer. Here's number 7. For number 7, we have the absolute value of this x minus 7 is greater than -3. Now this one's pretty interesting, we should take a look at. So there was one initial one we did in number 1 where that one was interesting. This one's interesting for a different reason though. Here on the left side we have the absolute value of an expression, but on the right side we're saying it is greater than a negative number. Now we know absolute value is always going to be 0 or higher. The only time it's 0 is if it's the absolute value of 0, otherwise it's always positive. So if absolute value is always positive, then it's always going to be greater than -3, right? So in this case, we can say here that our answer is going to be x equals all real numbers. Okay, so a little bit different than the first problem where we said there were no solutions. Here we can say that there's all real numbers because any value for x is going to make this true. And if you're not sure, you can actually just make up any value for x now, plug it in into this inequality, and you're going to realize that any number you plug in is going to end up spitting out a positive number on the left side or even 0 on the left side, and those numbers, no matter what, will be greater than -3. And while we're at it, if you're curious about the symbol for all real numbers, you may see this little fancy R symbol. And going back to number 1, if you want to see, you may see this symbol of no solution, which is kind of like the 0 with a slash through it. So For number 1, that one was no solution just because you can't have the absolute value be negative. And then over here for number 7, we have a special scenario just because absolute value is always going to be 0 or higher. So it's definitely, any value is going to work here because it's going to be greater than -3. Okay, let's go ahead and try number 8 here. For number 8, we have the absolute value of this 2x minus 7 that's less than or equal to 6. There's no issues with this one. It's not a special case or anything. We just have, there are definitely values that are less than or equal to 6, so we can go ahead and get started. We have, when we split it up, 2x minus 7, that's going to be less than or equal to 6. That's going to be one scenario. And then we have 2x minus 7 is going to be greater than or equal to -6. All right. On the left, let's go ahead and add 7 and add 7. If we do that, then the -7 and +7 will cancel out on the left side. We're going to get 2x is less than or equal to +13. And then we go ahead and divide by 2 and divide by 2 on both sides here and get that x is less than or equal to 6.5 or 6.5. Over on the right, we can go ahead and add 7 and add 7 to both sides. If we go ahead and do so, that -7 and +7 are going to cancel out again. And we're going to get 2x is greater than or equal to +1. Then dividing both sides by 2 here, we're going to get another decimal or a fraction. We're going to say here that x is going to be greater than or equal to 0.5 or half. And to write our final answer, we can say it two ways. First, we can say x is greater than or equal to 0.5, and we can say x is less than or equal to 6.5. Or if you want to put these together, we can do so as well and say 0.5 or half is going to be less than x, which is going to be less than this 6.5. These would be two ways of writing our solutions here. Here's number 9. So copying this down here, we have 12 plus the absolute value of 5 minus x. This whole thing is going to be less than or equal to 9. And what we're going to do here is take away 12 from both sides of this inequality, so we have the absolute value isolated. So taking away from 12 from both sides here, 12 minus 12 is 0. We're going to get the absolute value of 5 minus x on the left side, and that's going to be less than or equal to -3. Now, before we go ahead and split this into two different inequalities and start solving, keep in mind that this one's actually pretty interesting. If absolute value has to be 0 or greater and it can't be negative, then how could it be smaller than or equal to -3 here, right? Simply just not possible. So please make sure you look and are paying attention to what's going on before you start just solving. And we can say here that this inequality, absolute value inequality, is not going to have a solution, right? So don't waste any more time on it. We can say it's no solution or use this symbol, which also means no solution. Let's check out number 10. All right, so let's start by copying down this problem so that we can start isolating that absolute value expression. So let's go ahead and just copy this, and then let's go ahead and start by getting rid of that +1. To do that, we can go ahead and take away 1 from both sides here. Taking away 1 from the left side, 1 minus 1 is 0. We're going to get 2 times the absolute value of x plus 7, and that's going to be greater than or equal to 6 on the right side. And then to get rid of that 2 in front, we can just go ahead and divide both sides by 2. 2 divided by 2 is 1, so we just have the absolute value of x plus 7, and that's going to be greater than or equal to +3 on the right side. Now, checking to see if we should keep going, we get greater than or equal to 3, which is a green light. We can keep going here just because there's plenty of positive numbers that we could solve for. So let's go ahead and separate these out. So we're going to get x plus 7, and that's going to be greater than or equal to 3. And then our second one here is going to be x plus 7 is going to be less than or equal to -3. Okay, so on the left side, let's take away 7 and take away 7. If we do that, we're going to end up with x is greater than or equal to -4. And then on the right here, if we take away 7 and take away 7, we're going to see here that we're going to have x is less than or equal to -10. Putting these two pieces together, we can basically just say that x can be less than or equal to -10, or x could be greater than or equal to -4. This would be our solution. Here's number 11. For number 11, we have the absolute value of x plus 2 over 3 minus 4 is greater than or equal to -3. So we got quite a bit going on here. I'm just going to go ahead and copy this down so that we can work on isolating this absolute value expression. So we have that on top. We're dividing by 3. We're also subtracting 4. So we'll deal with those in just a moment. And this is greater than or equal to -3. To get rid of this -4 on the left side, let's go ahead and add 4 to both sides of the inequality. If we go ahead and do so, then they'll cancel out and we're going to get the absolute value of this x plus 2. That's going to be over 3, right? And that's going to be greater than or equal to +1. At this point, let's go ahead and multiply both sides by 3. That'll help cancel out the 3's that we see on the left side at this point. 3 over 3 is 1, so we're just going to get the absolute value of this x plus 2. That's going to be greater than or equal to +3 on the right side. Now let's go ahead and check this before we move on. Sure, there's plenty of values that are greater than or equal to 3 and they're positive, so we can go ahead and split this up into our two different inequalities now. So one of them is going to be x plus 2 is greater than or equal to 3, and our second one is going to be x plus 2 is going to be less than or equal to -3. Solving the one on the left, let's take away 2 from both sides. 2 minus 2 is going to be 0, so we're going to get x is greater than or equal to +1. And for our other one, we can go ahead and take away 2 from both sides here. If we do that, 2 minus 2 is 0 again, so we have x is less than or equal to, and then this -3 minus 2 is going to be -5. Putting together these two parts, we can say x would be less than or equal to -5, or we can say that x would be greater than or equal to +1. This would be our solution. Here's number 12. For number 12, we have 4 times the absolute value of x minus 5 minus 3 is less than or equal to 13. So before we can go ahead and split anything up or consider doing that, let's go ahead and copy this down and move some things around so we have the absolute value bars isolated. Okay, so here's our original problem here. First, we're going to move the -3, so we can go ahead and add 3 to both sides here. The -3 and +3 are going to cancel out, so we'll have 4 times the absolute value of x minus 5, and that's going to be less than or equal to 16. Okay. Now we just need to get this 4 away, so 4 is multiplying by it, so let's go ahead and divide both sides by 4. 4 divided by 4 is 1, so we can go ahead and drop that and say the absolute value of x minus 5, that's going to be less than or equal to +4 on the right side. Okay. Now, there are some positive numbers that are less than or equal to 4, so we can continue. So let's go ahead and split this up. We can say we have x minus 5, that's going to be less than or equal to 4. We can also say here that x minus 5 is going to be greater than or equal to -4. Solving these, we can add 5 and add 5 on both sides. If we do that, we will end up with x is less than or equal to 9. And for our second inequality, if we add 5 to both sides, let's see what happens there. We're going to end up with x is greater than or equal to +1. Putting these together, we could say that x would be greater than or equal to 1, and x would be less than or equal to 9. Or we can also combine these and just say that 1 is less than or equal to x, which is going to be less than or equal to 9. This would be 2 ways of writing our solution. Alrighty, for number 13, we have 3 times the absolute value of this 2x minus 4 plus 3 is greater than or equal to +9. So we don't have that absolute value bar isolated, so let's go ahead and copy this whole thing down so that we can move things away from it. So this is going to be our original absolute value inequality, and let's go ahead and get rid of this +3 by subtracting 3 from both sides. Okay, so if we subtract 3 from both sides, we're going to still have 3 times the absolute value of this 2x minus 4 on the left side, and that's going to be greater than or equal to +6 on the right side. And then we can go ahead and divide both sides by 3. That way that 3 in front will cancel out to make 1. So we have the absolute value of 2x minus 4, and that's going to be greater than or equal to +2. Okay. Now, sure, there's plenty of numbers that are greater than or equal to positive 2 that are positive that we can work with here. So let's go ahead and now separate and then solve. So we can write 2x minus 4 is greater than or equal to positive 2. And then we can say 2x minus 4 is less than or equal to negative 2. All right, so those are two inequalities. Let's go ahead and solve them. We can add 4 and add 4 to both sides here. If we do that, we're going to get 2x is greater than or equal to 6, and then divide both sides by 2 here, and say that x is greater than or equal to positive 3. For our second one, we can add 4 to both sides. If we add 4 and add 4, we're going to get here that 2x is less than or equal to 2, and then we can divide both sides by 2 and find that x is going to be less than or equal to 1. Together, we can go ahead and just say that x would be less than or equal to 1, or x would be greater than or equal to positive 3. This would be our solution. Here's one final problem. Number 14, we have 2/3 times the absolute value of 3x minus 1 minus 5 is less than or equal to negative 1. So let's go ahead and just copy this whole thing down so that we can go ahead and isolate our absolute value expression. So we have this 3x minus 1 that we really want to get by itself. We have minus 5 is less than or equal to negative 1. All right, so to get started here, let's go ahead and add 5 to both sides. If we add 5 and add 5, then that minus 5 and positive 5 will cancel out, and we're going to get 2/3 multiplied by the absolute value of 3x minus 1. And then we're going to have that be less than or equal to positive 4. Then to get rid of this 2/3, we can divide both sides by 2/3, or just multiply both sides by 3/2. Whichever way you want to think about it. That's called the multiplicative inverse. Everything with that, the 2 3's and 2 2's will cancel on the left side here. So we're just going to have the absolute value of 3x minus 1 on the left side. And that's going to be less than or equal to. And 4 times 3/2, the 4 and 2 will cross cancel to make 2 and 1. 2 times 3 is going to be 6. All right, so let's go ahead and check this. There are positive values that are less than or equal to 6, so we are good to go here. So splitting this into two different inequalities, 3x minus 1 is less than or equal to 6. We can also say here that 3x minus 1 is going to be greater than or equal to negative 6. Okay. On the left side here, let's add 1 to both sides. If we do that, we're going to get here 3x is less than or equal to 7. And then to get x alone, we can divide by 3 and divide by 3. We're going to see here that x is going to be less than or equal to 7/3. On the right here, let's also add 1 to both sides. If we do so, then we're going to be left with 3x is greater than or equal to negative 5. Then we can go ahead and divide by 3 and divide by 3 and find out that x is going to be greater than or equal to negative 5/3. All right, so putting these together, we can either say x is going to be greater than or equal to negative 5/3 and put the word and here, and write x would be less than or equal to 7/3. Another way we could write this, because this is an and inequality, is put negative 5/3. That's basically our lower bound here. That's less than or equal to x. And we also know x has to be less than or equal to 7/3. So x has to be bound between those two. These would be two ways that we could write our solution. Alrighty, so there you have 14 different practice problems on solving some absolute value inequalities. Just be on the lookout for when you have the absolute value bars isolated to look to see if the number that's on the other side is negative, and if you have a less than or greater than symbol there. Okay, so I can kind of let you know when you have your no solution or your all real number scenarios, but otherwise you're just solving these problems that have an and situation or an or situation. If you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.